Start with the first question today, being Q1. Factor completely 32x minus 18x to the third. So I'm looking for common items between both numbers. I can tell you first of all that they're both even, so I can automatically divide out a 2 from them. When I do that, I'll have a 16x minus, it's going to be a 9x to the third. And on the outside, we would put the 2 because, well, we divided it out from there. When we do that, we know there's still something else we can pull out of this, so we're going to look again and say both of the values have x's. So we're going to be able to pull an x out. We then look at the degree or the exponent of each one of them, and we see how many we can pull out. Because the lowest degree is just x to the first power, we're only going to be able to pull one x out. So we're going to pull one x out from both of those, and that means that I'm going to go to having 2x 16. And now that we've gotten rid of that x, it's no longer there, so we won't need to worry about that one. And then it will be minus 9. And since we took one x away from both of them, we're going to take x to the third and drop it down to x to the squared. All right? Now, at this point, we're going to realize that the 16 and the 9x squared are a perfect square system, and we're going to factor those one more time to factor this completely. We could have just said, oh, we pulled this out and it's factored, but there is another step to it. Because when it comes to perfect squares, you can set it up so that you have the square root of the number there. So the square root of 16 would be plus the square root of 9x squared, and then it would be the square root of 16 minus the square root of 9x squared. We'll do this real quick, and we'll find out that these pieces become 4 plus 3x times 4 minus 3x. And we're going to just take the 2x that we had up here before and bring him down to the outside. So completely factored form of this equation would be 2x times 4 plus 3x times 4 minus 3x. And we can prove this by formulating it back in and foiling the numbers together. Wait, I didn't get to question 5. Whoops. Question 2. Question 2, factor by grouping. So factoring by grouping, I need to figure out, grouping requires me to have 4 different variables. And both of them here in the center are just going to be a regular x value. This on the end is going to be a number, and the one up here is going to be an x squared. That's usually what they are before we turn it into this form here, which is a trinomial. So I need to identify what 2 values will add up to the 10x. And if I go to this, okay, so I could do the AC method, which takes the value of A and the value of C. I'm actually going to change my line thickness because it's starting to really cut into me there. And I multiply them together to get 24, because that's just 8 times 3. At this point, I'm going to look at the different ways that I can get to 24 that will equal 10. Okay? So I got 1 times 24. I've got 2 times 12. I've got 3 and 5. And 4 and 6, I think. 4. No, not 3 and 5. 3 and 8. My bad. 4 and 6. At that point, we know that it'll just switch to 6 and 4, and it'll count all the way back up the way it came out. So we already have all the factors for them. Is there anything on this tree that I can add or subtract together to make a 10? We look at that and we go, yeah, 12 and 6 will work in there. So that means that my two variables are going to be 12 and 2. And since it's a positive 10, that means I have a positive 12 and a negative 2. So I go up here and go, why would you choose 4 and 6? 4 plus 6 is 10? Okay, but...
So it has to add 10 and multiply 24.
Mm-hmm. Yeah. But I also know that I have a negative number. Because the 8, right, the A has a negative value, so I know there will be a negative number. Right. We're just looking at, we could plug both of them in and then refoil them to test either one. And it'll happen really quickly, and we'll realize which one works or not. But I'm going to go with the 2 and the 12 because I like the 2 and the 12. I might be wrong. If I'm wrong, then we'll have to go back and do it again. But at this point, that would be 8x squared minus 2x plus 12x plus 3. So looking at these now, remember how we factored the small things earlier and we were going, how do we pull things out of this? If I looked at that first set and I looked at this second set, we're now going to go to a different step type. So I'm going to change the colors real quick. At this point, I'm going to say, what can I pull out of a negative 8 squared, x squared minus 2x? I'm going to be able to pull out an x for sure because both values have an x. And more importantly, both values are divisible by 2. So I'm going to pull a 2x out of there, actually, because they're both negative signs. Pull negative 2x to the outside. When I do that, I'm then going to go back and I'm going to divide. I'm going to divide everything by that negative 2x. So I divide negative 8x squared by that. It'll give me a 4x plus 1. And that gives me an internal value. That internal value, I want to keep it. So what I'll do is I compare this internal value to the other half and go, how can I turn that into this? Well, I've got a 12x there and I want to make it a 4x. So if I divide that by 3, that would make 4x. And if I also divide the other part by 3, it'll become 1. So that actually works. So I'll say that I pull 3 out of this, I get a 4x plus 1. This is the fun part about factor by grouping, is we have the stuff on the inside and the stuff on the outside. And we're at this point in time going to take the stuff that is on the outside here, and we're going to stick it together in a box all by itself. Negative 2x plus 3. And then the other box, we're going to just keep what we had before. Because both of these boxes are the same exact item, we're just going to say copy-paste 4x plus 1. Is this my factored solution? Well, I can't simplify either side of it. And if I FOIL them together real quick, I'll do negative 2x and 4x equals negative 8x squared. I then go outer, FOIL, yep. So it would be minus 2x. And then I do inner, which is 3 and 4, which would be plus 12x. And then I do 3 and 1, so plus 3. I bring these together to be 10x. And at that point, I know that I have the same equation. Therefore, I have properly factored by grouping. So for question 3, factor completely. At this point, we can look at 81 and 192 and understand that they're probably going to be cube roots because x is to a cubed value. So we are going to have to use the AB formulas. However, we also can tell that 81 and 192 are both divisible by 3. So let's pull 3 out of there first to make them both a simplified form. Smaller numbers are better to work with. So if we were to divide everybody by 3, 81 divided by 3 would be, I want to say 26 or 27. I'm going to get one of the students here. 27? Okay. And the 192 is going to be 64? Okay, that's scary that I can remember that. 64. So, and that's just because we divided all of them by 3, so we can have the 3 on the outside as a part of the factoring, because we want to pull everything out to its prime level. But here we're now looking at a formula where we need to have, I'm going to draw this in a different color, a plus b, okay? A plus b, and a squared minus a times b plus b squared. And this all goes back on the fact that a is this guy and b is that guy. So now we're going to go back to writing in our numbers. So that means that we're going to have it as this is not going to be fun. So now back to recording. Sorry about that, guys. So when we're doing this, we have to take the values of these two numbers, and we're going to have to square root them, so, or cube root them in this case. So the cube root of 27x cubed plus 64. And then we're going to turn these into a and b. So the cube root of that will be 3x, because 3 times 3 would be 9, times 9 times 3 would be 27. And the x value goes from being a cube down to just being a regular x value. Get where? Do we have to cube these? Or did I get the 3x down there? Which part? Because I looked at this whole situation and said, in order to find the cube root of it, I have to figure out what these cube rooted numbers are for each individual variable, and then I'm going to plug them into the formula. Because that's what a and b are. A and b are the variables after you've cube rooted them. So in order to find a, which is here now, and to find b, I have to cube root the entire equation here. So when I cube root 64, that will be, I think it's 8? No, that'll be square root. Cube root will be 4, because 4 times 4 times 4. So plus 4. So if I know that b is equal to 4 and a is equal to 3x, I can now plug them into this formula and go 3x plus 4, parenthesis, and then we'll do a squared, so that'll be your 3 times 3, which will be 9x squared minus, and then we'll do 12x plus 16. And the only other thing we have to add on to this factorization is, remember, we pulled a 3 out in the beginning, so we're just going to slap it on at the end here. So we would say that it is 3 times 3x plus 4 times 9x squared minus 12 plus 16. This is the following ordered pair solution of the linear system. So we're just going to plug in these numbers over here for the x's and the y's and see if they actually equal their answer. So in order to do that, we're going to take a -2 and we're going to take a 1 and we're going to. So at this point, we'll put in a 3 and we'll put in a -2 plus 4y, which is going to be a 1. We'll run this through, and then we're going to equal that to -2. At this point, we're going to plug in our numbers, and our 3 times -2 is going to be a -6 When we take negative 6, we're going to add 4 to it because 4 times 1. Does that equal negative 2? Let's check. Negative 6 plus 4 will equal negative 2. Negative 2. Does negative 2 equal negative 2, everybody? Yes, cool. So that means that we know that this works in that equation. So let's plug it into the other one and see what the other one works. So that was equation number 1. Now we're going to take those numbers and we're going to plug them in for equation number 2. So at that point, we've got negative 2 times negative 2. Now going to go negative, and then we're going to do y. The y value is a 1. And it's going to equal 3. We're going to plug these in, so this is going to become plus 4, and minus 1 equals 3. Does 4 minus 1 equal 3, everybody?
Yeah.
Yes, cool. So that's 3 equals 3. So we know that it works for both of them. So it is a solution to both lines. Question 6, solve the following systems by elimination. We could eliminate these numbers as are with fractions and look for greatest common factors. However, I don't like any fractions. Fractions are not a thing. We like division. So looking at this, if I know that 2 is divided by 5 and 1 is divided by 3, and if I was looking for a common denominator between the two of them, what would be a common denominator between 5 and 3? People go, okay, 15, that sounds like a good one, but I'm actually going to go a step higher and go to 30 because I can do a really cool thing if I go to 30. If I multiply everything by 30, I can also keep the 3 in numbers. So, but if I want to multiply everybody here by 30, it'll get me out of fractions, and it'll also set it up so that 2 of them will cancel out. If you use 15, you'll have to then multiply one of these two sets by 2 again for the numbers to cancel. Yep.
Why 30 though?
Because if we do it by 15, we'll still be half of the size that we need for the numbers to cancel each other out on the graph. Right. So what I'm doing is I'm going to eliminate everybody at the same time by multiplying everybody by 30. So for example, if I multiply everybody here by 30, just making sure whatever he did here makes sense. Yes. Okay. So multiply everything by 30 on each one of them. I'll end up with a, is it 12x? Yeah. 12x plus 10 equals 90. Then you've got a 10x equals 180. So when you get to these numbers, and the reason you get to these numbers is you multiply 30 by 2, which would give you 60, and then you divide it by 5, which would give you 12. You multiply 30. What? Because this is, okay, so if I was to multiply 30 by 2 over 5, it's the same as saying I'm multiplying 30 by 2 and then dividing by 5. That's why I say it's not a fraction, it's division. I'm just going 30 times 2, divide by 5. It's what it is. That's the fraction over there, right? That's how you type it in a calculator. It's the same way that you look at it every day. It's just, see how it's a... Right. So it's better if I just did them all at 30. Now I'm going to multiply the top one by 1/2. Yeah. If I multiply this one up here by 1.5, so that, because remember, we're using elimination here, I'm going to get this number for y value to be 15, and it'll cancel out with the negative 15 down there, leaving me with just x values and number values. Do you see why we're going there? I'd have to figure out a common number between both 12 and 10 and get them both to that number. Bigger, not smaller. Bigger number that they're both common to, which would be 120.
Yeah.
I don't want to make my 90 and 180 multiply by 120, because then I'd start going into 6-digit numbers, and I don't want that. So we're just going to do it by the 1.5, where it gets scary. Which, by the way, you can do most of this with your calculator, just by plugging them in and hitting graph. And then hitting second, and then hitting the trace button, which turns into calculate, and pressing the number 5 for intersection. I'm saying this. Well, we've got to still eliminate them and then figure out each variable, then plug those back in. I'm seeing the look on your face. You're confused. So I've got to eliminate these. Okay, so when I know that I'm going to take this, I'm going to rewrite it down here after I've done that part. So if I do 1.5 times 12, it's going to be times 3 and then divided by 2, which will give me 18x plus 15y equals 135. And then I'll just put the other one on the bottom being 10x minus 15y equals 180. At this point, we can add these. Hello? There we go. Add these together to cancel out the y value, because the y value is negative and positive. It'll disappear, and then from there we'll add 18 to 10, being 28x equals. There we go. 5, carry this, carry out the 1, so it's going to be 1, so it'll be 21. So 215 will equal 28x. 3? Did I missed a 1? Yep, thank you. This is why I need my students to stop me. So then we're going to divide both of these sides by 28. Do we think that 315 will divide into 28? No, it won't, but it'll be 45 over 4. How? You're going to hit you're going to hit the math key on your calculator after you've done your thing. You're going to hit fraction, so you're going to hit enter, and then you're going to hit enter once more. And it's going to tell you that it's 45 over 4. So we know that x equals 45 over 4. At this point, we need to find the y values. Now that we know that one of them is going to be 45 over 4, we can plug that into the other equation to find out what y is equal to. No, we're only halfway done. We have to find the other half, which is actually a lot easier. Because remember how we did the 12x up here, and we have the one that's the 10x? We're going to pick the 12x one because I like the bigger numbers. So 12 times 45 over 4 plus 10y will equal 90. Because we used this number earlier, so we're just plugging the number back into that set so we can then get what y is equal to. And that'll be 135. I need a calculator. 45 over 4 divided or times 12.
135.
Thank you. I need to check. Y equals 90. Well, then we can subtract 135 from both sides. So we'll get 10y equals 90 minus 135, which is 45, right? Negative 45? Negative 45, right? Just trying to make sure that that's, yeah, negative 45, okay. Thanks for the check, buddy. So then we're going to do 10y equals negative 45, divide both of those by 10, and then we'd say that y equals negative 45 over 10, and x equals 45 over 4. My lovely calculators, I would like this in decimal form, if we can. So the first one. So 11.75, and the second one? In decimal form. -5. Okay, so at this point, if you were to graph those two, and you used an intercept command on your graphing calculator, it would read that the point 11.75 and -4.5 would be where these two lines intersect. We're going to solve the following system by substitution. We're looking to turn one of these values into just being variable equals the rest of the equation, and then we're going to plug that in for the other one. I think that we're going to want to change this first one here because I don't have to multiply or divide as much on the other one. So what I'm going to want is I have a positive y value sitting on this side. So I'm just going to move the actually do this side, or no, I should do it. Right, so what I could do is, well, no, it would actually become a positive x because we're taking a positive x and putting it on both sides. So that would be y equals x plus 9, which is a really good set, and we can plug this in over here. So then what we'll have is x minus 3, and instead of doing y like we normally would, we're going to take something that we know y is equal to and insert it in here, which is, come here, you, come. Ah. So if we do that, we're going to equal -1. Now we're going to distribute the 3, so we'll have x minus 3x plus -3 times 9 is, no, minus. It's going to be a divisionary line. Minus 27 equals -1, right? So at this point, we're going to merge our x values together to give us a -2x equals, and then we're going to add 27 to both sides. This gives us 26 on this side, so -2x equals 26 as our number. We'll then divide both sides by -2, canceling these out, and that'll give us x equals 13. So at this point, if x equals 13, we'll look back up at these numbers and say, which one would I rather plug it into? Who looks easier to plug an x into? The first one or the second one? I'm hearing first one. I like the first one because I go negative, box. That box is going to be my -13. And then I'm going to go plus y equals 9. Or I could just have plugged it into the other one and just added 9 to it. But we're going to do it this way. So we have a negative on the outside of the x, and we have the -13 on the inside of the box. It is the x, so we're going to turn this into positive 13 plus y equals 9. At which point we'll subtract 13 from both sides of the equation, and that'll give us y equals -4. Yes, 4. And we now have the value of y and x. That means that at the point 13, -4, these two lines will intersect each other. All right, so question 8, solve the following system by graphing. First thing that we have to do with these is we have to turn them into y equals mx plus b in order to graph them, because we want things in slope-intercept form because they look prettier that way. So the first thing I'm going to have to do for this one on this side here is we're going to have to move the x over. We're going to do that by adding x to both sides of the equation, which gives us -2y equals x plus 1. At that point, we can divide both sides by 2, leaving us with y equals negative 1/2 x minus 1/2. So at this point on the next one, we're going to do the same thing, and we're going to add 2x to both sides. That's going to give us y equals 2x plus 2. And now we're going to graph these two items. I'm going to graph this one first because it looks prettier, and I'm going to make it the color, oh dear, come on. And make it the color of purple, I think. If I can find the color purple. Yep, find the color purple. So this one is going to be purple. If I look at my chart over here, that one says that it's going to have a b value of 2 when x is at 0. And if it goes up to, it goes over 1, which I can't really do on this chart. So what I'm going to do is I'm going to go down 2, and I'm going to go negative 1. And that's going to give me a line yeah, let's put it on there. That looks like a good line for it. Touch, there we go. That'll be my purple line. Now we're going to make my other line, which I'm going to say will be my red line. So yes, you can absolutely graph them at these points. If you graph this on your graphing calculator, that's exactly what it's going to show you. But we can do this just by looking at the b value, saying it's going to be a negative 1/2. So I can start it right down there at that negative 1/2 point. And it says that I can go down 1 for 2 over, or what I could do is I can go 2 negative and up 1, which would give me right there. Now, if I have these 2 points, I could use those points in order to draw myself a line from here to there. And what you'll realize is at the point negative 1, 0 will be an intersection between the purple line and the red line. And that'll tell us that our solution will be negative 1, 0. Ta-da! Set up. Solve the following system using any method. What method do we want to use, guys? Do we want to graph it? Do we want systems of wait, what? Eliminate. Substitution. Okay, substitution sounds like a great method, guys. We should work with substitution. So if we're looking for substitution, we want to turn one of these into a single variable. And I see this x here is all alone. So I think we're going to use him. So in order to do that, we're going to have to add 2y to both sides. And that'll be negative x equals 2y minus 3. And then we're going to just divide everything by a negative 1. So that'll be x equals negative 2y plus 3. So we have that. Now we can take this item and we can substitute it into the other equation. So if we do that, we'll then end up with 4y equals negative 2 of negative 2y plus 3 plus 10. We're now going to distribute the negative 2 for this part of the equation, which will be 4y minus 6 plus 10 equals 4y. At this point, we can then put in, oh, there's a problem here. Will this actually work? Right, we'll end up canceling both the y's. Is it no solution?
Yeah.
Because 0 will end up equaling a positive 4. And that means that it does not exist, which means these are two parallel lines. Why did I divide by negative 1? X was negative and I wanted it to be positive because the other value for x is not.
So I can divide by negative x.
You, what, divide this, both sides by negative x? Is what you're saying? If x is negative, there's an imaginary -1 in front of it. I'm just canceling it out with an imaginary -1 down there, and it just means that this is negative there. I could have just flipped both sides of the equations and flipped everybody's sign, but an easier way of explaining it is doing that. Magic. Voodoo magic. What? Okay, so we're still doing this. We've got that canceled. We know they're parallels, and they're never going to touch. So the answer will be... okay, I'm not the only one having this problem, right? Does not exist. DNE.
Is that the same thing as no solution, or is it?
Yes, you can say no solution in this case. Or you should say no solution in this case. But if they're asking what point is it, it does not exist. There is no connection between it.
Why just switch the sign? Like the negative to y.
Okay, so 10. Explain how you can tell how many solutions of a linear system has using these two methods. So algebraically, we will know that there is one solution if x ends up equaling a number and y ends up equaling a number. If one equals a number, the other one will equal a number. Graphically, what we'll see is two intersecting lines. So you'll have one line here and one line there. When you're looking at a graph, you'll see the two lines for one solution intersect at one point. If you're looking at it algebraically, x will just equal some number. If there are no solutions for the two, and this is algebraically what we were talking about earlier when we worked them out, and we got some number equals another number, but they're different numbers. For example, if 4 equals 2, we know that there aren't any solutions because they're just two parallel lines. And we'll see that graphically by two lines that seem to be going on forever and never touching each other. As for an infinite amount of solutions will end up equaling 0 equals 0. Everything will cancel out as you're doing elimination or substitution. Or you'll see it as the same number as the same number. So, for example, 7 equals 7 would also be an infinite solution set. And you'd see that because you would have one line produced and then a second line over the exact same line produced again on your graphing calculator. And that'll tell you that they're the same line. They're going the same direction, they're going the same altitude, same angle, and they're going to, at every point, have an infinite amount of solutions with each other because they all are right. And that's how 10 explains out. Here, Andy earned $12,000 during his summer vacation. He invested part of the money at 10% and the rest at 5%. If he received a total of $100 in interest at the end of the year, how much was invested at each rate? So this is where we look at it, and we know that he invested, well, we know one's going to be at 10%. So let's say that bond A was at 10%, and bond B was at the 5%. Right? So we know that if we put all the money together that he invested for bond A and bond B, that would be the $1,200 that he earned. So we know that the A plus B will equal $1,200 because that's how much money he had to invest. So he just put it all in there together. So if we added both those up, we would know exactly that they would equal $1,200. On the other hand, we also know that if A, which was by 10%, right, which will be 0.1, I guess is, yeah, that's going to be the best way to represent this. A times 0.1, or 0.1A, plus, and B is going to be 5%, which would be 0.05B, will equal, how much do you get? $100 back?
Yeah.
So we know that at some point these two added together will equal $100 after the first year. So our goal is to figure out how much he put in A and how much he put in B. This is very similar to an equation set up for systems of linear equations, and because they're not asking us how to do it, I would heavily suggest using the substitution method or graphing the equations. If you were to graph the equations, you'd have to turn it into y equals mx plus b form, but we're just going to plug and play the numbers using the systems of, we're going to do substitution. So in order to do substitution very quickly, I can move either the a or the b value across to the other side of the first equation. We'll just do it with the b value. So we can say that a would equal $1,200 minus the value of b, and that kind of makes sense. If we took the money out for b, we would have whatever was left over equaling a from that $1,200. So we have that, and then we have our multiplication system. So let's plug in the value of a into our second equation. So 0.1 times 1,200 minus b plus 0.05 b equals 100. And this looks a little bit messy, but we're going to start dealing with decimals. So we're going to distribute this 0.1 to both of these. So that means I'm going to have 120, because we took out one of the tens place. We multiplied everything by 10%, minus 0.1b plus 0.05b equals 100. Now I'm going to want to start isolating variables. I'm going to take the 120, I'm going to subtract it from both sides because I want all my numbers on one side and all my b values on the other. So when I do that, I'll end up with negative 0.1b plus 0.05b equals negative 20. I'm very close to an answer on b, so we're just going to say negative 0.1b plus 0.5 will give us negative 0.05b equals negative 20. And now we can divide both sides by 0.05, which if we do that, we're doing division and decimals at the same time, so we can just multiply it by that decimal. Do that. Getting a calculator. What? No. Add a 0 in front of that. Thank you. Either one. No, multiply that. I bet. Multiply that. No. Go divide. Do the opposite of whichever one. Thank you. There we go. So negative 20 divided by 0.05 would give us negative 400. So that means, wait, negative 400. You also did it wrong. You need a negative there on your 5. Yes, because all of them were negative beforehand, so that would cancel out, and we know that b equals $400. And then we can just go plug that back in and say, well, if it was $1,200 for the total, and we have $400 in B, that would give us $800 in A. So A equals $800, B equals $400. We know how he split his money up. Or next time we'll just find his. So one number is 9 more than another whole number. 5 times the first number is 3 less than twice the second number. These are two different systems that we're going to have to work out. So if we say one number, I'm going to say every time we say that, it's an x. And then another number is going to be y. So we have one number, x, is, so equals 9 more than another number. So y plus 9. That will be my first equation. I know that's terrifying sounding how we pulled that out of there, but we get to do it even better. So 5 times the first number being x. So 5x is 3 less. So that means that 5x minus 2. Yep, 5x. Three less than doesn't equal 3 less. You just swapped it around so it looked better.
What?
5 times the first number is equal to 3 less than twice the second number.
Yeah. So if you do the subtraction, it should be negative.
Okay.
It's just the way.
Okay. So let's see how I did it. So we could make this equal here, but what they did is they actually just subtracted the 2y there and then made this equal to a negative 3. Because we're saying it's equal to 3 less than twice the second number. We could have done the 5x minus 3 equals negative 2y, or we could do 5x minus 2y equals negative 3. Either one interchangeably. So because 5x minus 3 will equal negative 2y, we could just swap their positions and put the negative 2y on this side. The reason we want to do that is because we want everything to be on the same side of the equation. Yes. Yep. Right, but you want to do it this way because that way we can set up the 2 y's on the same side of the equation. Why is it 2 what? What?
Like I'm thinking like 5 times the first number, 5x.
Mm-hmm. Yeah.
And the second number, something 2 equals 2y minus 3.
I would like this.
Right, but they can work interchangeably. And if I put y on that side of the equation, I can't write it up to break them through. Yes. The 2 has to have the y because it's twice the second number. It's not 3 times the second number. It's just 3 less than. Yes, you'll have the same thing, but the problem is you'll have to flip it around anyways at the end because we still have to set it up so that the 2 will run through and we cancel it. Yep. No. Because what's going to happen is I'm going to end up having it as this here gets multiplied by negative 2. That way I can make this negative 2x plus 2y equals negative 18. And then the bottom one can now equal 5x minus 2y equals negative 3. Because if I do it this way, see how the x's and the y's are on the same side? Because I had to move this over, and it would have been x minus y equals 9. And then I just multiplied that by negative 2, so that these 2 y's can cancel each other. This y value is being positive, this y value being negative, so these 2 won't exist anymore, and then I'll fit these together and make it so that it's 3x equals negative 21. And at this point, I'll look at that and just divide both sides by 3, giving us x equals negative 7. I've got 1/2 of the answer there. I'll just go plug that back into either one of these. And I know that one number is 9 more than another number. So that means if I took negative 7 and I put 9 more on it, I would get negative 7 minus y equals 9. And then I would just move the negative 7 over, so I'd add 7 to both sides, and I would get that negative y equals 16, which means that positive y equals negative 16, giving me the point negative 7, negative 16. All right?
Fine, all right.
Did you find the numbers? Do we understand this is still systems of linear equations just haunting you for the next part of this exam, right? Okay. Good. Okay. Gonna look back over 14 now. Because we've got one question left, which is, wait, no, two questions left. Oh, the concert ticket. The concert ticket's going to be the same as the money one that we did earlier, only we're going to be counting peoples instead of dollars put in each one. And then we're going to compare it through to the amount collected from both peoples. We ready to go to the next question, guys? What?
Can we try to take off the Y? Wait. Does it have, can you take off the X?
Take out which X? Okay. So taking out the X value would be like trying to skin a cat backwards. It's that means I would have to find a multiple between 2 and 5 that would cancel out, which would be 10. So I'd have to multiply the entire top equation by 5 and the entire bottom equation by 10 to cancel out the Y's. Or cancel out the X's instead of the Y's. Because I'd have to get this 5 and this 2 to cancel each other. Yes. We're putting this up online for you guys to have in a PowerPoint. Yeah, it's going to be on the little tickets that we're going to pass out at the end of this. So you guys can look at the entire screenshot of this, zoom to about that ratio. And you'll be able to see it play through systematically as I draw it. Oh, that was on record the whole time. $50 adults and, wait, is it 150 or 50? So 50 people are going to go in there. And that's going to equal our adults, which is our A, and our B, which is our children. So A plus B equals 50. And we know the adult tickets cost $5 and children tickets cost $1. The school collected in total $210. And that equals the adults being charged $5 every time they walk in there, and the children being cost $1 every time they walk in there. So these are two different equations, and they're setting up in a way that we could eliminate them. This is a good one for elimination. All we have to do is make these two B values not equal to one another. So we're just going to take this top one, and we're going to make all things in it negative. When we do that, we're going to turn it into negative 50 minus A minus B. So negative 50 equals minus A minus B. And then we have the other one, keeping it 210 equals 5A plus B. And when we do this, we'll now sum them together. We will get rid of B completely. We will take away 1A, which will leave us with 4A equals, and we're going to take away 50, so that's going to then be 160? Okay, so 160 will be 4A, which means we can divide both sides by 4, and that means that we're going to get 40, what? 260, why? Where? What? Yes.
You're right. I was right.
You hit him. So we'll end up dividing 160 by 4, which is 40, equals A. So we know that there are 40 adults, and since there are 50 people going in, that tells us that there will be 10 children and 40 adults. So how many adults and children are coming into attendance? We now have the answers for those right over here. Okay, so we're going to solve the systems of linear equations graphically. And we can do that with a graphing calculator or without. But first thing we have to do is turn both of these into their proper slope form. So we're going to start with the red one, which is negative x minus 3y is greater than negative 1. And we're going to add an x to both sides of the equation, giving us negative 3y is greater than x minus 1, in which case we'll divide both sides by negative 3. And that will be switching our sign because we have inequalities, not regular equations. So we'll have y is now less than, we'll type it in as 1 over 3. So negative 1/3 x plus 1/3. And the reason why we did it that way is because we needed to distribute 3 across each one so we could type this into the calculator later on for anyone who wants to check their work with the graphing calculator. Now we're going to do number 2, and we're going to do it as a blue color. So for this one, you've got a 2x minus 2y is greater than or equal to 2. All right, at this point, we're going to subtract the 2x from both sides, leaving us with negative 2y is greater than or equal to negative 2x plus 2. We will then divide all sides by negative 2, flipping the signs, making it y is less than or equal to a x plus what? Yeah, x minus 1, because we'll just split the 2 over each side. The 2 x's cancel, and the other one gets turned into a 1. So that will be our blue line. So then looking at this, I will say for my blue line, my b value, which is where I will cross the x-axis, will be at negative 1. And from there, I'm going to go up 1 and over 1, and that's going to be a 1-to-1 ratio. So when I do that, I'll just draw out better looking line here. It's not the best. So that's what my line will look like, and then I can go back and draw the red line. So now that I've got that done, our red line is going to start at 1/3. So I could start at positive 1/3. So it'll be about here, but we'll figure that out pretty quickly because it's going to require us to go 3 down and 1 over. So it will have, for every one line, it will go 3 over. Oh, wait, so no, we'll go to that one there. My bad. It's more of a hand-drawn line, but we have to remember that this red line is going to be a dotted line because it is not equal to, and it's going to be everything below the red line. And the blue line is everything below the blue area, which means that we're going to have a net area of purple, which is going to be everything below both line sets in here. And that's how we would end up shading this, for the most part. And that's the last question. So I'm going to